I recommend that you download what's called Anaconda. And Anaconda is, it includes Python, the language. It also includes a lot of libraries or packages. I'll use those terms interchangeably, that are really helpful when using Python. And so we recommend using Anaconda because it keeps everything organized and everything in one folder, and it makes downloading new packages, which you will probably have to do because that is kind of part of the computational world, then it organizes all of them for you automatically, so you don't have to think about them. So that's really great, but the one downside is they are about ½ GB, so they're a bit large for the initial download. But as I said, once you download it, you should be good. So I will put the link in the Zoom chat. So if you click on that, and again, you don't have to do it at the moment because it will take up a lot of internet. You'll see options for different computers. So you see Windows, Mac OS, and Linux. So I think most of you probably have Windows. And then you can download whether you have a 64-bit or a 32-bit computer. You can download whichever one works for you. Okay, I will start to share my screen. Where do I do this? Here we go. Okay, can you all see my screen? Or, well, I guess let me know if you can't.
Yeah.
Perfect, thank you.
Yeah.
I appreciate that. Yeah, so this is the link that I just sent you. This is to download Anaconda, which is downloading Python as well as libraries that you need. And so you can click on whichever one you need for your own computer. And this here is the COESSING website. So it's coessing.org. If you click on the 2020 school plus 2021 mini school, which is what we are right now, you can scroll down and click on Python programming. And here there are a couple kind of video tutorials done by others, not by me. And it shows you, it's a video of how to install Anaconda, which comes with all these other packages like Jupyter and Spider and other things. So you can watch this and just follow the instructions and you can see what it's supposed to look like. So that's really helpful. So one other option, if you have good access to internet, is you can use Google Collab. And this is basically a Python, you can use Python online. So you can just go to the Google Collab website, and then you can start doing Python computer programming, and you don't have to download anything, but you do need a solid internet connection. So we can go through that if you want, but mostly I'll be focusing on the like a local version of Python, because that's what I have. So there are more materials here, so we'll go through these. So these are kind of walkthroughs just to get you started. So we'll do some of these at the moment. And here are previous tutorials that I gave in the 2020 school, so a few months ago. So if you want to watch that, you're welcome to. So anyway, here are a lot of good resources on this webpage. So I wanted to start by showing that. So one thing to keep in mind as we go through this, and please stop me and ask questions. If there's anything you don't understand or are curious about, please interrupt. So one thing that I want to point out is that I have a Mac computer. A lot of this stuff is very similar, but there are a few noticeable differences with Windows. So just keep that in mind. It won't look exactly identical. So I'll just close that for now. So when you, this actually is a picture of where I grew up. This is my hometown, a view from my backyard. So when you first download Anaconda and you want to open it up, you can go on Windows, you go down to your search menu in the lower left corner, at least that's where it used to be. And you can search for, I'm doing it in the Mac way, Anaconda, and you'll see that it comes up with Anaconda Navigator. So let's open that. So I'm opening up Anaconda Navigator at the moment. Oh, it's launching on my other screen. And I'll show you what that looks like. And that's, here it is. Oops. Sorry, it's just popping up a little message for me, which I'm ignoring. Okay, so this is what Anaconda Navigator looks like once you open it. And you can see that it has all of these things here. So it has Jupyter Lab. I'll let you know what that means in a minute. It has Jupyter Notebook, and it has several other different things, Spider, RStudio, a few other things. So these are all editors that allow you to write code. So, because if you're going to write computer code, you need to be able to write it somewhere and be able to run the code. So these will all do that for you. So my preferred method, so the one that we focus on at this point in the COESSING school, is called Jupyter Notebook. So I will click launch, and I can start. You'll see it pulls up these commands, and it pulls up this. This is what it looks like. Don't need that. So Jupyter Notebook is an editor where you can write Python, as I mentioned before. Actually, it doesn't have to be Python. Oops. You can write several other languages as well. You can do HTML or R or several other languages, but it works in your web browser. So this is called Safari. It's the web browser that I use on a Mac. It's the default web browser. On yours, it'll be whichever your default browser is. So that might be Chrome or Firefox or something like that. But don't be alarmed. You're actually not using the internet. So you're using the browser, but not the internet in this case. So once you've downloaded Anaconda, you have Jupyter, you can run Jupyter Notebook, you can run Python and everything without using internet. So that's really why it's a nice benefit to have it on your local computer, so you don't have to use internet. So here you can see a list of folders that are on my computer. And I will click through until I get to the place where I want to be. So I keep my things in documents. I'm going to do things from COESSING. So I'll click on that. I'm going to click on COESSING 2020. And here we see, so this is a list of all of my folders and lots of different documents on my computer. So you can see everything that I have here. When you see this has a little book here, and the extension is .ipynb. That stands for IPython Notebook. So notebook being, this is a Jupyter notebook. IPython means interactive Python. So I will click on that to open up a pre-existing Jupyter notebook. So what I just opened is the notebook that I call is kind of an introductory walkthrough of Jupyter. So we get a hang of what Jupyter is, what these Jupyter notebooks are. So yeah, let's dive right in. Unless there are any questions, am I going too fast or too slow? Please let me know. So you can read these things that I've written here. So what's nice about these notebooks is you can put text as well as code. And so that's what I'm going to take you through here. So you can read these things that I wrote. The idea is that you can walk yourself through all of these steps. So if you see here, I can double click, for instance, in this cell. So Jupyter notebooks function with cells. And if I can just start double clicking on everything, and you'll see that they're actually all made up of cells. So here is the same. Everything is just a cell, even this top one. And you see that some of them have different sized font than the others. And that you can do by putting a hashtag here. So when we're just using plain text, So if you want to document things in your notebook, which is very helpful, you want it to be in Markdown mode. So I can click here. This is actually a little menu. And you can say code, and that's if you want to write Python code, or Markdown. And Markdown is just a fancy way for saying like text. So we want text here because this is my title. And I can click run, and then it shows up just as plain text. And you see that it's quite large, and that's what this hashtag means. If I put another hashtag in, it gets smaller, and it keeps getting smaller. And so that's how I can control the size of the text. So these are all very kind of minor points, but very nice for making your notebooks very readable. So if we jump back down over here, we have one hashtag. So that's the biggest header. So that's why I wrote largest header here. And I can click run. Equivalent to clicking run, you can type shift return or shift enter. So you hold down the shift key and then press return, and that evaluates the cell as well, which is often faster. Here again, you can see I have two hashtags. It's slightly smaller, and you can just keep putting hashtags and it keeps getting smaller with some italics. And you can see there, I just made it even smaller. You can do some formatting. So here I've put these dashes here, and if I evaluate this cell, you can see it makes a bulleted list. So that's nice. So one thing that's talking about here that's very important is all of these buttons at the top. So this plus button here at the top, if you can see my cursor up here, if I click that, it adds a cell below the selected cell. So I can just keep clicking that, and it adds these new cells here. So that's useful if you want to add a new cell to do some more computation or type some more markdown. Or if you added a cell and you want to delete it, you can use this scissors here, and that's, if you hover over it, it tells you, it says cut selected cells. So I can cut and it deletes that cell. This cell here, if I hover over it, it says copy selected cell. So I can copy the cell I'm currently on, which is this, onto some Python coding cell. And this one here is paste. So if I paste it, then I just copied and pasted that cell. So that's very useful. The up and down arrow moves the cell up and down. So that's how you can switch the order. Run evaluates the cell, as I mentioned before. And a few of these are a bit, will come a bit later, so I'll mention those later. And this one on the far left is the save button. So these notebooks automatically save every, so here you can see, well, there's some unsaved changes at the moment, but it kind of auto saves every once in a while. But if you want to make sure that you save at a certain point, then you can click save, and then it says last checkpoint a few seconds ago. You actually can go back to a checkpoint. So if you click save, like I just did for this checkpoint, you can actually, if I then make some changes and I type some stuff and then I'm like, oh shoot, I didn't want to do that. You can go back and you can revert to the previous checkpoint. So it's a way to kind of keep track of your versions, which is quite nice. I'll get rid of that cell. Okay, so on to some actual coding. So this is a code cell. You can tell it's a code cell, first of all, because it says code up here when I have this highlighted. It also says in, and that's meaning that's the input. So that's where I actually type. And then the out is what the output is. So in this case, I'm just doing a very simple addition, 5 plus 7, and what do you know? It's 12. So that's Python, that is using Python. This is doing a squared number. That's so you do a squared by using 2 asterisks. You can do mathematical expressions. You can print out words. So if you write print and then you use these quotation marks, then you will print out the words, as you can see here. You can assign variables. So you can say x equals 3 plus 7, and then you can print and you print this variable x here, and it prints the value of x down here. So I'm moving quite quickly, but these are kind of some of the things you can do, some of the basics of just kind of math in Python. I think we had someone new join. Ebenezer, welcome. I've told all of the others that feel free to interrupt with questions at any time. It would be great to hear from you. I hope I'm not going too fast already. But yeah, feel free to chime in anytime. Okay, so now that we have all of these basic commands, there are going to be a lot more sophisticated commands that you might want to use. For instance, if we wanted to take the sine or cosine of a number. And to do that, we need a different library. So it doesn't come in the basic Python. But it does come in this library called Numpy, which stands for Numerical Python. So Numpy is a library or a package, and it comes with Anaconda. So if you download Anaconda, as I suggest, then all you have to do is say import space numpy. And then I use this shorthand, so I say as np. That's basically giving NumPy a nickname of np. So that when I want to call any function within NumPy, I just say np dot, and then sine. In this case, if I want to take like the trigonometric sine function, and here I'm saying of pi, which is also defined in the NumPy library. So let's evaluate that. So you can see here, so I actually haven't evaluated any of these cells. So this in and then the number is the number. So this means that this one here means that it's the first cell that I've evaluated in this notebook. So if I click here and I evaluate, which again is holding shift down and pressing enter, then it says 2 because it's the second cell that I've evaluated. And so that's how you know when it has evaluated. When I'm evaluating, there's a little star that sits here. And so sometimes it takes a long time to evaluate something if it's a complicated expression, and you'll see a star there. And that just means that it's processing. You also have this up here in the right-hand corner. You have this little circle here. Hopefully you can see that it's maybe I should make this bigger. There, that's probably better. Should have done that a bit ago. You have this circle here that is empty at the moment. It's just this outline. But while a cell, see if you can watch that when I evaluate this cell. Yeah, so it's very quick because it's a very quick evaluation. But when something is evaluating in your notebook, then this circle will be filled in. So it'll be a solid black color. And that's when you know that some computation is still going in your notebook. Okay. How is everyone doing so far? Am I going too quickly? Am I missing anything? Any questions?
For me, it's okay for now.
Okay, cool. I haven't completely lost you yet. Cool. It's funny being, yeah, virtual like this. You don't get much feedback. So, so yeah, please stop at any point, and this goes for anyone if you have any questions or don't understand. So another key aspect of programming is what we call arrays. So these are kind of like matrices, if you've done that in math. And it's just like a sequence of numbers, kind of. So in this case, I can say, so this is a NumPy function, np dot, and then dot array means create an array. And if I put these 4 numbers here, then it will create an array with these 4 numbers. So this is what I've done here. So this square bracket means it's part of an array. And you can see it has the numbers that I listed, 1, 3, 6, and 11. So that's the array. Here I've also defined an array in a different way. So using array, I can just specify each of the numbers that are in the array. If I use this function called arange, and I say 10, then it creates an array of length 10 that starts with 0. So that's what we see here. So it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's a bit confusing, but Python starts its indexing at 0. As you can see here, so indexing meaning like things like this. So if you have your first, what we might say is the first value of this array is actually the 0th value. So when in Python, count starting with 0, which is a bit confusing sometimes, but is actually quite nice in a lot of other cases. So in this case, you want to count 10 numbers, but starting with 0, and that's why you end at 9. So that's an important feature. And if you have ever done MATLAB, maybe a few other languages, they start indexing at 1. And so that is a noticeable difference in Python. So that's some arrays. So often in like scientific research, if you're using Python to do some research or modeling or data analysis, your data will come as usually sets of arrays. So depending on your data, it might be more than one dimension. But if you take temperature measurements, maybe this is your temperature measurement, 1, 3, 6, 11 or something. So arrays are going to be really crucial to understand moving forward. Okay, let's do some plotting. So here we have it's a new library. So before we had Numpy for numerical Python, this one is called Matplotlib. And so you can see that it has plot in the middle. So it's the mathematical plotting library. That's why it's Matplotlib. And it's for plotting, clearly. And you import that on this line here. And again, I'm using this nickname PLT. So that when I call functions from this library, I'll say PLT dot, and then whatever function I want. This might seem a bit tedious, but it's actually quite nice for organizing your code, so you know which libraries have which functions that you're using. And you can call this whatever you want. Like I could say import matplotlib.pyplot as banana, and then I could call it as banana.plot. But I won't do that because there are some standard things such as PLT that everyone uses. So if you Google anything or you're talking to someone, it makes much more sense to do this. Cool. So this line up above is also very important and is kind of funny. So it's a percent sign. Hello. Hi, Dan. Thanks for joining. Yep. So we're just going through some of the basics here, and I've told all the others, please feel free to interrupt with questions at any time. Don't be shy. This is informal.
Okay, thank you.
Yeah, of course. So this here is a percent sign. So I write percent matplotlib with no spaces, and then a space inline. What this does is it makes our plots show up in line in our notebook. That's what inline means. So if I don't do this, actually, I don't think I've evaluated this yet. So if I just delete this and I import the library and then I plot, I must have imported it before. So sometimes if you don't do this, if you don't have this line, then this plot won't show up. You'll see this line, but you won't see the actual plot. So that is important to do. Side note, if you're in Collab, you do not need to do that because it automatically will make your plots show up. And it's possible that newer versions of Jupyter will do the same, which is maybe why mine worked. But anyway, that's important to know. So if your figures aren't showing up, you're missing this line, most likely. I also want to mention coding is you have to be very exact. So like if you're reproducing this line, you have to say import, there needs to be a space. These all need to be lowercase. So it's case sensitive. So if you have an uppercase letter or if you misspell anything, then it won't work. But usually it tells you what the problem is. So for instance, let's just say I misspell Matplotlib and I just say Matplotlb. So I'm missing the I between the L and the B. So if I evaluate this cell, there's an error. So module not found error. So it's telling you what the error is. So module not found, meaning it doesn't know what library this is. And it says there's no module named Matplotlib. And I'll say, oh, of course, that I was silly. I misspelled it. I add the I, and then it works. So error messages are usually your friends. Most of them are quite useful, and they say what goes wrong. So don't be alarmed. Yes, Dan.
Yeah, so about the error messages, sometimes when you see them, it's difficult to understand what it means.
Yeah.
How best do you overcome that?
So in Jupyter Notebook, you often get, I think the one that I just did was pretty short. So often you get, so I just did the same thing again, deleted this I get an error message, and there's often the top bit kind of explains the details. Usually the bottom bit is the most helpful. And this is in Jupyter Notebook. And so when this happens, at the moment, I would just only look at the bottom. It says no module name Matplotlib or Matplotlib, and then I would adjust it. Sometimes, well, very frequently, at least for me, I'll get errors that are about 5 times this long. So it's like many lines. Yeah. And then still the bottom line is the most helpful, usually. But the top bit often points to which line is wrong. And so here you can see the arrow points to line 2 because it's the second line here. So that's also really helpful, especially if you have many lines of code in your cell and you don't know which one is wrong, it'll point to which line is wrong. So those are kind of the 2 things that I usually use. Very occasionally, like here you can see, oh, well, no, this line. So this one is a very easy error. I'll have to see if we can come across a more complicated error. But those are the 2 things that I get. And if I don't understand an error, I copy the bottom part and put it into Google, and usually someone has an answer. So that's my...
Yeah, that usually works.
Yeah, but you don't usually have to copy the whole thing. So that's the tip, is usually just the last line. So yeah, good question. And if you use, like a lot of these are pretty good. So this tells you there's no module named this. Some of the newer Python libraries. So so all of these things are open source, meaning anyone contributes to them. And that means that you all can contribute as well. I actually just started a postdoc where I'm starting to help contribute to some packages, which is pretty exciting. And that means that a lot of those error messages, when people are writing their own code, sometimes they take a little time to get to really be polished. Or when people are creating their own, sometimes they're not very good at writing very specific errors. So sometimes an error will show up and it just doesn't do a good job of telling you what the error is. So again, copy the bottom bit, Google it, and hopefully that will help me find the answer. Okay, let's put that back in, get that out of the way. So now we can make a plot. So I'll define an X. So I'm making an array using the A range like we used up above. And I'm setting it to go from -2 pi to 2 pi at intervals of 0.1. And then for Y, I'm saying, let's make it be the cosine of X. And then I can plot X and Y like this, do plt.plot, and it creates this. You can make it a bit fancier. So you can, this top line increases the figure size. So you can see this one's much bigger than that one. And this is in roughly in inches, like 12 by 8 inches. But the way it shows up on the screen is a bit different, depends on your resolution. Here I'm saying I want the color to be red, so we can see that. And the line style, I say I want it to be dashed instead of solid. So these are just several different options that you have to make your plots look interesting. Here I'm adding a title, so plt.title. Oops, I can get this title here, and I can even specify the font size. So we could make this like 46, and then it will be giant. I think I have to run this one first. And now I have a giant title. So you can make that whatever you want. And it's also always good practice to label the X and Y axes. So these labeling is kind of something that I've tried to get in the habit of all the time. So you can do that with a plot.x label, and then you have X, and then you can specify the font size again, and the same for the Y. So that's a bit of Numpy and Matplotlib, which are key libraries that you will likely use. Here's one that's a bit more sophisticated, and it's called Pandas. I don't know what kind of data you all work with or what you want to use Python for. But if you have data that's kind of like in lists of things, so if you're going out and taking like temperature data or something in like one specific location, then you'll probably have like a list of temperature and a list of times or something with each temperature. So in that case, you would use Pandas. That's kind of the go-to library to use for that kind of data. If you have three-dimensional data, which is also very common in like oceanography and ocean-related fields, then this might not be the best way to go, but then you can use something called Xarray, which we can talk about later, or I might get to in my tutorial tomorrow. So Pandas is just a great way to organize these kind of list kind of data. So to import Pandas, we do same kind of thing that we did before, import Pandas, and this time we're importing it as PD. And they have these structures called data frames. And that's kind of how we store multiple arrays. So you'll see down here what I mean. So here I'm saying df, so I'm just calling, this is a variable, I'm just saying df equals, and I'm defining a data frame. And I'm saying in the first column, I'm going to call it A, and I want it to have the value 1. The next column will be called B, and it will have this timestamp, which is another kind of form of data. And so on, you can say column C, we're going to have a series, which is kind of just like an array that we saw up above, and so on. And you can see here what it looks like. So if I just type df at the bottom, then it prints out the df that we just defined. So in this data frame, we have these 6 columns, A, B, C, D, E, F, and that's what we labeled here. So you can see in column A, it's all 1.0, and that's because we said 1.0 here. In B, you can see that it has the form of a date. So in this case, it's actually, I don't know which way this date is. I think this means January 2nd, but in different countries, we do it in different ways. But anyway, this is a date in 2013. C, so this is basically just an array with value 1. So again, we have 1s. For D, we have a Numpy array, which is what we saw before. And it's all 3. So we've got 3s. And then E here is a different type of data called a kind of categorical, which we don't have to go into much at the moment. And then F is this string of letters. So anyway, there's a lot going on here in this one cell, as I'm realizing. And this is all of this, as I mentioned before, is available on the website or on Slack, or if you can't find it, message me on Slack and I can get it to you. So you can kind of go through and play with these. So this is what the data frame looks like. And so often when you have data, you might have A being your measurement. Let's say it's temperature, I'll continue with that example, and B might be the date that you took the measure. So if you go out every day and you take temperature in one spot over a year or something, then you'll have the date, maybe a time as well, and then you'll have a corresponding temperature value. And so you have this kind of data in list form. And so that's what Pandas is really good at, organizing all that and making any calculations quite easy. So I was explaining all these different types, like data types. Here, if you say df, so I'll evaluate this. If you evaluate df.dtypes, then it tells you what type the data is in each column. So here you can see there are a lot of different ones. So float means a decimal, basically. A date time here means that's what we have for a timestamp. So that's kind of a really handy feature of Pandas, is that it handles dates. And so you can have it as a date time format. And this NS here is because it's stored as nanoseconds, but you can display it however you want. So you can see here that I've displayed it by day, month, and year. Let's grab some water. How's everyone doing? Still following along okay? All right, cool, thanks. So again, we have a float, and the 64 and 32 is how many bits are stored. So a 64-bit float means that it just has more precision. So it would be like 1.0000, many more zeros than this one. So that's the difference. That doesn't really come up very often. An int means it's an integer. A category is one I don't use very often, so I really won't go into it, but that's another object. That's another type. An object is another type as well. So, so anyway, you have all these different ways of storing data, and Pandas can allow for that. So a lot of things, previously you had to have all of the same data type if you made different columns. And so that's one powerful aspect of Pandas, is you can store something as a float and a date time in the same matrix. So if this is my data set here and I want to access the values that are held in column E, then I just say df, and I have these square brackets, which means kind of accessing elements of df. And then I call E, because that's the name of the column I want, and then it'll print it out for me. So there are a lot more things that you can do with Pandas. And the Python lab, so this is just kind of the introductory walkthrough. There's also a Python lab, and that uses Pandas. So you'll get a bit more hands-on experience with that if you do that. Here are a few, so we won't go into too much, but here are a few other libraries that are really useful. So CartoPy is a great visualization library. So that creates nice plots of maps. So you can do all sorts of different projections of maps, and you can select different regions. And there's a really great CartoPy tutorial on the COESSING website as well. And that was developed by someone I work with here who's really great, Josue. So you can check that out. NetCDF4 is, and notice that this is capitalized. So when you import, it's just important that you remember that. This is a good library for using, for importing NetCDF files, which is NetCDF is a format that you can save data in. So I used to use a lot of NetCDF files. And so I use this quite a lot, although an alternative currently is Xarray, which is a bit harder to learn, but is actually much more powerful. Xarray, so that's one I just mentioned, a very powerful library where you can basically, if you have a data set, for instance, in a netcdf format, you can plot it in one line. So instead of saying like load the data, do this, you have to grab the right variable, all of these things, you can do it all in one line, among many other great features. So I have a very short kind of walkthrough of Xarray and Dask as well, as part of this COESSING Python tutorial package. So I won't do that today, but I might do it tomorrow if that's of interest. Yeah, I have a few tips here, which you're welcome to read on your own time. I don't know why I wrote that, but there's probably a reason. Okay, so that was kind of the first walkthrough. Oh, one thing I should absolutely mention is, so actually let's go back. So notice I have different tabs here. So when I clicked on this, this notebook, it opened it up in a new tab. So I can go back to this tab and I can now see all of those folders and documents that I saw at the beginning, or that I found at the beginning. If you want to start your own new notebook, which is very important, you go up into the top right corner over here and you click on New, and you'll click on Python 3. So there are different versions of Python. Python 2 is being phased out, so don't use Python 2. I don't think you will be able to at this point. And so Python 3 means which language, basically. So we call it a kernel. So if I click on this, Python 3, then it opens up a brand new notebook with no cells yet. So the first thing I do when I open up a new notebook is I click on Untitled and I name my notebook. So I can say new example notebook. And now that's the name. I can't tell you how many times I've forgotten to do that, and then I end up with a bunch of untitled notebooks and can't remember which one is which. So that is very important to name your notebook something you will remember. And then you have these cells. You can switch them to Markdown if you want to write a title. And yeah, or you can have a code here and say, this is code. And then you have a code. Yeah, are there any questions about anything I've said so far? Nope. Okay. Oh, yep.
Oh, not really a question. I think it's been a nice tutorial. Yeah, I wanted to find out, you are using the Python for like the graphs you showed.
Mm-hmm.
You could do something similar in a program like R.
Yep, absolutely.
Yes. So how do you, okay, so as someone who wants to say maybe not necessarily be a programmer, but be able to apply this kind of programming skills in their field of work, do you advise that you just focus on, say, maybe one program, or combine, because it's said that R produces better graphical displays? Yes.
Ooh, interesting.
Thank you.
Yeah, good question. I think we have a new person. Titus, hello, welcome. So back to your question, Dan. I don't think that I had heard that R produces better visuals, potentially. So R and Python are actually quite similar. That's fine. It might have better, it has different packages, and different libraries. So in different communities, they're used, different languages are used. So from all of my experience in the ocean and climate and atmosphere community, it is heavily a Python community, or MATLAB, and that's mostly the older people who are stuck with MATLAB because they learned that. And most of them want to learn Python. So in that sense, I would recommend using Python. But I don't actually know R very well. But once you know a language, it's much easier to learn another one. So if you're really starting at the beginning, then I'd say focus on one language and get that kind of mastered to a certain degree. It doesn't have to be super mastery, but I would say get to know one language pretty well. And then if you find in your field that others use R, that's totally fine. You can still use Jupyter Notebook for R, so a lot of these things still apply. The libraries would be different and the syntax would be different.
Okay.
But yeah, so R, I know that R is used a lot in the statistics community as well as in the economics community. I don't know about every community, so it may be that people around you are using R, and maybe that makes sense for you to learn. It's also open source, so it's very similar to Python in that sense, which is kind of nice. So yeah, I have nothing against R, but I don't see many people in my research community using it. So
Thank you. Okay.
yeah.
Dan?
Yes. Do you have a
Dan.
question?
Dan, quick.
Oh, you want to talk to Dan?
Yeah, Dan.
Yeah, hello.
Do you normally use R?
I'm now learning it.
I don't learn.
Like in my field, yes, in my field, that's what we are focusing on.
Oh, what field is that?
I'm in marine, but then I want to do a lot of statistics. So
Okay. Yeah.
so it's a marine program here, focusing more on statistics.
Yeah.
Okay.
Good to know.
I thought maybe you're an expert in R. Like I'll contact you then. Maybe.
No, I'm not an expert. I'm also still learning.
Oh, okay.
I think nobody really becomes an expert. Constant learning.
Oh,
I
okay.
agree.
Okay. Thank you. Okay.
Yeah. So yeah, sorry, I'm not much help with R. Yeah, I don't know too many people who use it in my community. So, but yeah, it would be very similar. See, I had a few things that I wanted to show. Sorry, I have this list. Okay, here's one thing that I wanted to show that I haven't shown previously. So if I go back here, which is kind of my main Jupyter Notebook site, if I click up here, well, first of all, you can see that this has the names of all the folders that we're in. So I went through documents, COESSING 2020. So I could just delete all of that, enter, and then I'm back at my kind of home folder. But even more interesting, if I delete tree here and type in lab, then it's going to start Jupyter Lab. So if you remember when I first started with Anaconda Navigator, I chose Jupyter Notebook, but Jupyter Lab was another option. And Jupyter Lab is basically the same thing as Jupyter Notebook, but it has a bit more features, I guess. So here you can see it says notebook, so I can still open a notebook using Python 3 or these other kernels that I have. So if I click Python 3, it opens up a new notebook for me, just like before. And we see up here in this tab that it's still called Untitled. And so in this case, I have to right click and say rename notebook to rename it. Test notebook. I always like to put underscores in these. So now I can rename it just as before, just a little different. And now I have cells. I can do the same thing. I can add cells, delete them. Everything is the same. I can have markdown, go back to code. And I can navigate folders here on the left. So when I click on this folder thing here, then I can still navigate to my documents, COESSING 2020. This is where we were before. And so here I can see quite clearly that these orange icons mean that these are notebooks, and green means that these notebooks are currently running. And that's because I had them open with all of you just a few minutes ago. So if I click on this here, up on the left, you see it says running terminals and kernels. So if I click that, oops, then it tells me which notebooks are currently running. And running means that they're open and that variables and everything are saved in them. So if I were to open these notebooks, they'd all be ready to go with all the cells having been run previously. I can shut down those from here. So if I'm done, for instance, I'm maybe done with our new example notebook, I can shut it down, and then it gets rid of all the variables and stuff. So if you're sometimes having memory issues, or sometimes I open up a lot of notebooks and forget, and then I come here and there's like a list of 20 and I just want to close them all because they're using up my computer disk space. So that's really useful. There are a few other things here that I haven't used as much, but this here, so, well, there are a few things that you can kind of, I'll let you play with these. You can still save the notebook. Yeah, revert notebook from a checkpoint. So these are all kind of the same things that we had before. Yeah. So anyway, this is one way to do it. You can also go back, you can delete lab and type tree again, and then you get back to our original. So that's kind of a nice little trick. So let's see. If you are here, and let's say you need to download a new library, I suggest clicking New and going to Terminal here. Then you can, so now this is a terminal that you can access files from. So if I ls, it'll list the files. From here, you can download new packages. And it depends what package you need. If you want netcdf4, for instance, you can say conda install netcdf4. And it should say that I already have it, hopefully, because I think I do. And it will do this. So it'll say, oh, it's getting the metadata. It's solving the environment, done. And yeah, so here it's saying I need to update something. And so I can type Y or N, so yes or no to proceed. So this is, I'm gonna say no, because I don't want to do that right now. But this is how you can download new packages. And it's nice to do it within this terminal, because then you know that it will be in the right folder for your Anaconda, because this is running through Anaconda. So sometimes it can get a bit confusing if you save download Anaconda somewhere, but it's kind of linked in different places. So this is my suggestion for doing that. Yeah, so I guess we're near the end of the hour at the moment. Yeah, any feedback, any questions on what I said, or do you want to look at other things? I have another session tomorrow if you can come, and I'm happy to go over things that you would like. Any questions that you have?
As for me, I think I was fine. Yeah, I followed. Yeah, so thank you. I want to take an early leave. Hopefully, I'll see you tomorrow.
Okay, yeah.
Nice seeing you again. Yeah.
Yeah, likewise.
Yes, and please. Yeah, I want to ask one more question. Yesterday, Dr. Fanetti from Italy, he had this session on ICTP. I don't know whether he recorded his session. I missed that.
Yes, it is recorded, and it'll be posted.
Okay. Okay, then I'll wait for it.
Yeah, so I'm actually the one updating the website, and so I'll be doing that in the next day. I think that recording is out. I'll have to see if it's. It might not be uploaded yet. But I think. Now I'm not sure if it was recorded. I'm not sure. I'll have to ask him if it's one of these. Yeah, Zoom ones. It might not have been. So I'll ask him. Yeah, he's great. So one other thing, certainly before we go, later today, there is a tutorial with Emily and Eben and Enrique, and they're going through open data. So they're going to go through all the different like free and openly available data sources. I shouldn't say all because there are lots, but they're going to go through a lot of them. And I really recommend that because, yeah, knowing what data is available is going to be really useful. And if you find a data set and you need help accessing it, I probably can't do it on the fly tomorrow because sometimes they're a bit tricky, but if you have questions, please come to me and we can, write some Python code to figure it out. Yes, Dan, do you have another question?
No, it's fine. Thank you very much.
I saw your raised hand, which must have been from before. Yeah, so I recommend the open data tutorial. I would like to do more of finding some good sources for data that you all can use in the future, but I definitely recommend going to that. So,
okay,
yes.
Lisbeth, I'm thinking whether you have maybe manual or the language, maybe like the commands, the input in Anaconda. You have a manual or something like a small book or textbook that you can share so that we can run through, so that we can understand the language, how to input data or information in Anaconda. I think that will help a lot. Yeah.
Yeah. So you mean like all of the functions I was using, like knowing like print and numpy dot sign and stuff. Yep. So those are all specific to different libraries, and I can absolutely find. So online you can find all of these things. Let's see if that gets it. NumPy reference manual. So here is, so you can see array objects. Let's click on that. So here it has some of the theory about what an array is, potentially more theory than you might need. Constructing arrays. Yeah, okay, so this is very theoretical. Here we are. Here are a few things. So this is, you can use the dot shape attribute. Yeah, so a lot of things are listed here. This might not be the best.
This is what I'm looking for. Yeah. This is what I'm talking about.
Yeah, so yeah, like NumPy has, whenever I Google something, like if I say NumPy sign, because I'm like, oh, I forget what the what the syntax is, it's almost always the top hit on Google, like especially if it's NumPy or Matplotlib, same thing. So it's, if you know which library it comes from and you know what you're trying to do, then you can usually find it quite easily. And so here it says dot sign, and then you put in your X, and it kind of has all these other options, many options. But most importantly, it has these examples here. So you can see np.sign of pi/2, and it prints 1. So I know sometimes it's a bit harder for you all with access to internet. So I think you might be able to download some of these, but it'd be a very, very big document. So the best is to use these reference manuals. If I go to the COESSING website, I have some resources. I don't know if I link that, but I should. So here there's some Python and Jupyter resources. So how to install Anaconda, some more tutorials, exercises from previous years at the school. And here are some kind of, oh, here we go, Python cheat sheets. And you can also, there are all these great online resources for learning Python. So these are kind of online tutorials. Some of them are videos. So here we go, videos. So online courses that are free. But these Python cheat sheets might be helpful. So Python basics. So this has a list, yeah, it lists a lot of the basics. So how to do squares, for instance, an integer, float. Yeah, this is for Jupyter Notebook. So it says what it is up here. So hopefully that's helpful. So here you can actually see Python, this is R, and this is Julia. So all three of those can be used in Jupyter. And here it has all of these things, how to execute cells, what everything in each menu means. So these are really great. And this is for NumPy. So yeah, I hope that
thank you very much. This is exactly what I'm talking about. Yeah.
Yeah, perfect. So did you catch, that's on the COESSING webpage and under resources?
Okay. Okay.
Yeah.
Thanks a lot.
Yeah. And for everyone here, I hope you're all in the Slack workspace. If you're not, yeah, let me know. We can get you added. But you're welcome to ask questions there anytime. I usually have Slack open because that's how I communicate with my groups, especially in this work from home culture currently. So I will, try and respond within a day or two if you have any questions, throughout the year. So don't hesitate to ask.
Yeah, Elizabeth, you can add me. I'm not on Slack. You can add me.
Oh, you're not on it. Okay. Could you send me your email? Okay.
I'll drop it in the chat box.
Yeah, that'd be great. I just have to figure out how to see the chat. There we go. When I'm sharing the screen, somehow it's hard to see the chat. Oh, sorry, I was missing everyone's chat. Great, thanks. Thank you all for using the chat. I didn't realize that I was missing these. To answer the question from Titus, yes, I'm recording it now, so I will upload this to YouTube and we'll post it on Slack and on the website. And it'll be on the COESSING YouTube channel. You can just find it there.
Okay, there you go. You have it. I'll put it there.
Yeah, thanks.
Okay.
I will copy it over. I might do it once the call ends, but I will copy it here. Yeah, are there any other questions now that I see the chat? It could be in the chat as well. If anyone else wants to be added to Slack, let me know. And yeah, I'll have another one of these tomorrow. I'll see who's there. I might go through like the Python lab, or could go through some of the other kind of more specialized kind of mini tutorials that I put up. So yeah, whatever is most helpful. Cool. Thanks, Ebenezer. I'll copy your email over as well. So Paul, I know you're in Ghana. Is everyone else also in Ghana here? Do we have some others from different countries? I'm actually in Australia at the moment, so it is nighttime for me. So once I end this call, I will be going to bed soon. And I know most of you probably just woke up. Okay, well, cool. Well, okay, cool. Ebenezer, you're also from Ghana. Well, cool. I'm so glad that you were able to join. Everyone here, thanks. And yeah, I'll add the two of you to Slack. Maybe I'll see you tomorrow, or maybe I'll see you on Slack later on. I will stop sharing my screen.
Okay.
All right, and I will post this video. It sometimes takes a little while to render, but maybe in a day or two. So yeah, any questions, post them on Slack, and I look forward to hearing from you later. Bye, everyone.
Bye.
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 Have a good night's sleep.
Yeah, thank you. Have a nice day.